Hello students, today we are going to learn exercise 2.1 of chapter polynomial. Here the first question is, which of the following expressions are polynomial in one variable and which are not? State reason for your answer. First question is 4x square minus 3x plus 7. Now we have to answer whether this expression is a polynomial or not. So we see the answer one by one. For that, first one, 4x square minus 3x plus 7. Now see, there is only one variable x with whole number power. So this polynomial in one variable. We have to check the power of the variable. Variable is x here. X raised to 2 power, x raised to 1 power, and here x raised to 0 power. So all the powers are non-negative integers, means whole number, and therefore this one is a polynomial. Second one is y square plus root 2. Now once again we have to check that what are the powers of variable. Here the variable is y. So here y raised to 2 power is there. Here y raised to 0 power is there. So the powers are once again whole number, and so this one is also a polynomial. We see the next one, which is 3 root 2 plus t root 2. Now in this one, fourth one is y plus 2 upon y. Here 2 upon y is given, means y raised to power 1 is there in the division. If we take it up, then y raised to minus 1 power comes, and so the powers of the variable y, that becomes negative here. So we require only here whole numbers, and therefore this one is not a polynomial. Now x raised to 10 plus y raised to 3 plus t raised to 50. All there are three variables, and all having the powers whole number only 10, 3 and 50, and so it is a polynomial in three variable. So this way we can see the questions further now. Question number 2 here. Write the coefficient. Write the coefficient of x square in each of the following. What is the coefficient of x square? That we have to answer here. So we can see here coefficient of x square is here. So 1 is here. So the first answer is coefficient of x square is 1. The second one is here. X square is here. Minus x square term is there. So 1 is present here. So the next one, coefficient of x square is minus 1. Third one, we see the coefficient, that is pi upon 2. So pi upon 2 is the coefficient for x square. Here x square term is not present, means 0 x square is there, and so the coefficient of x square term is 0. So this way we can see the answer for each one. First, second, third and fourth. Give one example each of a binomial degree 35 and a monomial of degree 100. So we have to write one binomial, means two terms are there, and having the 35 as a degree. So you can write here any number. So here it is written 3x raised to 35 plus 7. The next one is monomial for 100 degree. So we write 4x raised to 100. Now we see the next question, fourth one. Write the degree of each of the following polynomial. 5x cube is there, then 4x square plus 7x. So the highest degree term here is 5x cube. So highest degree in this polynomial is 3, and therefore degree of the polynomial is 3. 4 minus y square. 4 minus y square, the highest degree, that is 2. So degree of this polynomial is 2. 5t minus root 7, the highest degree for the variable in the term is 1. So 5t having 1 power. So degree of the polynomial is 1. Here 3x raised to 0 is there. 3x raised to 0. And so the degree here is 0. So that's a we see first one 3 is the degree, second one 2 is the degree, the third one 1 is the degree, and the last one there is a 0 degree. Now classify the following as linear, quadrilateral, quadratic and cubic polynomial. So either it is a linear polynomial or cubic polynomial or quadratic polynomial that we have to answer. So first one we see the polynomial having the highest power 2. So it is a quadratic polynomial. Next one having the highest power here 3. So it is a cubic polynomial. We see further here y plus y square plus 4. This one once again 2 power is there. So it is a quadratic polynomial. 1 plus x raised to 1 power is there. So it is a linear polynomial. 3t. Once again the power of the t is 1. So it is a linear polynomial. Then r square. 2 power is there. So it is a quadratic polynomial. 7x cube. 3 power is there. So it is a cubic polynomial. Now here exercise 2.2 starts here. Find the value of the polynomial at 5x plus 4x square plus 3x. First question, we have to apply x equal to 0. Second, in that we have to apply x equal to minus 1. And in the third one, we have to apply x equal to 2. So, we see that question. First question, p of x equal to 5x plus 4x plus 3 is already given to us. In which in place of x we apply 0. So, what we get? 5 into 0 plus 4 into 0 square and plus 3. 0 square is 0 and 4 into 0 is 0. 5 into 0 is also 0. So the value remaining is 3. P of x equal to 5x plus 4x square plus 3, in which now we apply minus 1. P of minus 1 we find out. So 5 into minus 1 plus 4 minus 1 square and plus 3. Minus 5 plus minus 1 square is 1. And so 4 into 1 and plus 3. So finally we get 7 minus 5 is equal to 2. The third one, px equal to 5x plus 4x square plus 3, in which we apply 2 now. So p of 2 is equal to 5 into 2 plus 4, 2 square and plus 3. So 10, 2 square is 4, 4 4 is 16 and plus 3. So 10 plus 16 plus 3 which is equal to 29. This way we simplify the next question now, in which once again we have to find out what is P0, P1 and P2. For each polynomial we have to find out 3 values. So the first polynomial is y square minus y and plus 1. For that we find out the 3 answers, P0, P1 and P2. So what is the given Py? Y square minus y plus 1. First one we apply 0. So 0 square minus 0 and plus 1. So the answer is what? 1. When we apply 1, then y square, so 1 square minus y, so 1 and plus 1. Plus 1 minus 1 cancel, 1 square is 1. Then P2, we apply 2. So y square means 2 square, minus y means 2, and here plus 1. So 4 minus 2 and plus 1. So we get here 3. Now the second polynomial is P of t given, which is 2 plus t plus 2t square minus t cube. In that also we find out 3 values, P0, P1 and P2. First we apply in place of t 0, 2 plus t given which is 0 plus 2t square, so 2 into 0 square minus t cube which is 0 cube is equal to 2. Now P of 1, so 2 plus t 1, 2t square, 2 into 1 square minus t cube minus 1 cube. So 2, then 1, then 1 square is 1, 2 into 1 is 2, minus 1 cube is minus 1, and so the final answer is 4. Now P of 2 we find out, that is once again 2 plus t, that is 2, then 2t square, so 2 into 2 square minus t cube, which is 2 into minus 2 whole raised to 3. So 2 plus 2, this one is 4 to the 8, and this one is minus 8. 8 cancel, so 2 plus 2 we get 4 as the answer. Now we see the third one. One more is there, third and fourth. So P of x equal to x cube is given. So P0, which is 0 cube equal to 0, P1, 1 cube is equal to 1, and P2, 2 cube is equal to 8. Question number 4 in that, P of x equal to x minus 1 and x plus 1. So first of all we apply 0. So x 0, minus 1 and 0 plus 1. So this is minus 1 into 1, which is equal to minus 1. We apply 1 now. So 1 minus 1 and 1 plus 1. 1 minus 1 is 0. 1 plus 1 is 2. 0 into 2 is equal to 0. Now P2 we apply. So x minus 1 means 2 minus 1. X plus 1 means 2 plus 1. So here is 1 and 3. 1 into 3 equal to 3. Now we see question number 3 here. What is question number 3? Verify whether the following are zeros of the polynomial. Indicate again them. So we have to check whether this value x equal to minus 1 by 3 is 0 of this polynomial. So how to find out that? If the answer is coming 0, then it is 0. If any other answer is coming, then it is not a 0. So first of all we apply minus 1 by 3 in place of x in the first given term 3x plus 1, and we check what answer is coming here. So we see it one by one. So here we start with, we check 6 1. First one is here. Minus 1 by 3 we apply whether it is 0 or not. So for that P of minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. So minus 1, 3 cancel, minus 1 plus 1 equal to 0. 0 answer is coming, therefore minus 1 by 3 is the 0 of a polynomial Px 3x plus 1. If x equal to 4 upon 5 is a 0 of a polynomial, then P of x equal to 5x minus pi is given. So we apply P 4 upon 5. P 4 upon 5 is equal to 5 into 4 upon 5. 5 gets cancelled. So we get 4 minus 5. So answer is not coming 0. Therefore it is not a polynomial. Third one we see. For the value of x equal to 1 and x equal to minus 1. So first of all we apply 1. So here 1 square minus 1, which is 1 minus 1 0, P of minus 1. So x square minus 1 is given, so minus 1 square minus 1. So 1 minus 1 is equal to 0. So 1 and minus 1 both are zeros of a polynomial x square minus 1. Now we see the fourth one. The fourth one, P of x is given to us x plus 1, x minus 2. In that, in place of that x we apply minus 1 and 2. So first of all P of minus 1 is equal to x plus 1 means minus 1 plus 1, and x minus 2 means minus 1 minus 2. This is 0 into minus 3 equal to 0. And P of 2 is equal to that we apply now x equal to 2, so 2 plus 1 and 2 minus 2, once again 2 minus 2 is 0, so 3 into 0 is equal to 0. Both answers are coming 0. It means what? X equal to minus 1 and x equal to 2. They are zeros of the polynomial. Now we see the fifth one. The fifth one is, if x equal to 0, then P of x equal to x square is given to us. So we apply 0 in the place of x. So here 0 square equal to 0. So x equal to 0 is also a 0 of a polynomial P x equal to x square. Okay, good.